orbit. What is the final formula we got? Minus by 8 epsilon naught. So En equal to minus me power 4 by 8 epsilon naught square n square h square. This is your energy of the electron when it is in its nth orbit. This is last class. Now for hydrogen atom, what happens to the atomic number? Hydrogen atom atomic number is 1. So for hydrogen atom, atomic number is 1. Now the equation here m is E. Charge, constant value, it won't change. 8, number, epsilon, naught, it's also a constant value. N, order, it will change. H, Planck's constant. Substitute all the constant values and he simplified. He got this value as minus 13.6 by n square EV. What is that EV? Electron volt. Usually we will use for energy as joule. Energy ki unit joule. Inga enna potirukom? Electron volt. So this is also another unit for energy. So I can also convert this electron volt unit into joules. 1 electron volt equal to how many joules? 1.6 into 10 power minus 19 joules. So I can also convert electron volt into joules or joule into electron volt. Anyway I can convert. Now for hydrogen atom, atomic number is 1. When the electron is in its first orbit, electron inge irukkalam, or first orbit la irukkalam, second, third, fourth or whatever it may be. When it is in its first orbit, E1, energy of the electron when it is in the first orbit is given by minus 13.6 by n into the 1 dana inge. What is n here? In a first orbit la irukku electron. Appo enna agum? 1 square. It will be equal to minus 13.6 electron volt. Now electron on the second orbit la irukku, n equal to 2. Appo enna agum? E2 equal to minus 13.6 by 4. Minus 13.6 by 4. Now divide pannita. Minus 3.4 electron volt. Same way can we see for this third orbit? Energy of the electron when it is in its third orbit, E3. Can you see the board, the last row? Minus 13.6 by 9 idoma, 3 square. 3 square 9 enginago? 9. Appa minus 13.6 by 9, it will become minus 1.51 electron volt. Energy of the electron when it is in the third orbit. When it is in the fourth orbit? No, minus 13.6 by 16 agum. Inno kammi agum. Appa minus 0.85 electron volt. When it is in its fifth orbit, minus 13.6 by 25, 5 square. It will be minus 0.54 electron volts. So this will be the, I can do it for all the orbits. It goes on like this. When the electron is in its infinite orbit, enga irukku electron infinite orbit la irukku, appo energy eppadi irukum? Anything divided by here, minus 13.6 by infinite. So the energy of the electron when it is in its infinite orbit will be equal to 0. So these are the values I am getting, isn't it? Now you look at all those energy values. Here the order increases. Number of order enna agudhu? First orbit, second orbit, third orbit increase aga. Energy enna agudhu? Increase agudha, decrease agudha? Enna? Energy decrease agudhu. Give a clap. Eppadi? See the negative value. Minus 5 greater or minus 10 greater? Minus 5 is greater. See the negative sign. You are forgetting about the negative sign. The values na paakuringa. Magnitude mattum da paathirukkeenga neenga. The negative sign shows as the order increases, this energy is approaching its maximum value. Positive value approach agudha illaya? Compare. Minus 13.6 vida idu dana greater. Idu vida next one greater. So when it is in its infinite orbit, it is become 0. So as the order increases, energy also increases. That is what negative sign. Usually what you will do, inge rendu inversely proportional order increase aga energy decrease agum nenikom. But the negative sign shows as the order increases, energy also increases and it approaches its maximum positive value. Now we know when an atom emits radiation. When an atom emits radiation, solunga. எப்பமா ஆட்டம் ரேடியேட் பண்ணோம்? Bohr what he told? When it is revolving in a circular orbit, அது stationary orbit, not radiating orbit. அப்ப அது emit பண்ணாது இல்லையா? அப்ப எப்ப emit பண்ணும்? When it jumps from a higher orbit to a lower orbit, the difference in energy level between these two orbits will be emitted in the form of radiation. அதுதான் Bohr சொன்னார் இல்லையா? அதுதான் second condition. Now, let for example, let E2 be the energy of the electron in its second orbit and let E1 be the energy of the electron in its second orbit. When the electron jumps from second to first orbit, the difference in energy level will be emitted in the form of radiation. Nu. Energy formula sollu paakalam. M e power 4 by n square h square, isn't it? Now I want to find out the frequency of the spectral line. I want to find out the frequency of the emitted spectral line. இப்போ nu என்ன ஆகுங்க? E2 minus E1 by H. We know what is the energy formula. தெரியுமா? E2 னா N2, N வந்து என்ன ஆகும்? N2 ஆகும். E1 னா N1 என்ன ஆகும்? N1 ஆகும். Can we write for this? So what happens to E1 and E2? E1 equal to minus me power 4 by 8 epsilon naught square. Yeah, can I write N1 square? 1 போடலாம். Let it be as it is. N1 square H square. So what is E2? me power 4 so I am going to substitute these two values in this formula for frequency. Common ஆ இருக்குறதெல்லாம் வெளிய எடுத்துடலாமா? எது common? U equal to m minus let it be as it is. Take the values. M e power 4 by h square. Clear? மீதி என்ன இருக்கு? 1 by n1 square minus of இந்த மைனஸ் இருக்கா? இங்க நடுவுல மைனஸ் வரணும்ல first. Minus 1 by n1 square minus of this minus. அப்ப என்ன ஆகும்? Minus minus will come plus E2 minus E1. N2 square minus N1 square. I can rewrite this equation. So take the positive term first, negative second. So what happens to this frequency? M power 4 by naught square H square 1 by clear. So this is the frequency part. What is wave number? What is wave number? I found out the frequency of the spectral radiation emitted. If by finding all these values, I can easily find out the spectral frequency of the radiation. Wave number na enna? Number of waves in unit time. Or unit time la ஆமா இந்த h போடலையே நம்ம. So it will become h cube. Clear? This h square into h. Now listen, what is wave number? Number of waves in unit time, we call it as the wave number, or otherwise how I can write this wave number? It will be equal to the reciprocal of the wavelength. How I can say the wave number? Reciprocal of the wavelength. So wave number symbol is like this. It will be equal to 1 by lambda. Now we know that C equal to nu lambda. From this, what is lambda? What is lambda? C by nu. 1 by lambda? Nu by C. So we know that wave number equal to 1 by lambda. So in the place of wave number, can I write this nu by C? Frequency by C. Frequency we have calculated. So to find out the wave number of the spectral radiation, I can write this as nu by C. Denominator enna agum appo C varum. It will be equal to m e power 4 by 8 epsilon naught square C h cube into 1 by n1 square minus 1 by n2 square. This will be your wave number formula. But if you see at the final formula, this common value la veliya eduthirukkom, all these are constant values, isn't it? Ellathiyume constant dane. So he told that this constant values he had taken it as r into 1 by n1 square by 1 to n2 square. This r is nothing but a constant value called Rydberg constant. இதுக்கு பேர் என்னமா? Constant. He calculated all this, substitute பண்ணிட்டு எல்லாத்தையும் calculate பண்ணாரு. He got this value for r as 1.094 into 10 power 7 per meter. இது constant value நீங்க by heart பண்ணி தான் வாங்கணும். எங்க constant value வருது? எப்படி epsilon naught value ஞாபகம் வச்சிருக்கீங்க? C தெரியும், H தெரியும், M, E எல்லாமே constant values தான். You have to by heart, no other go. அதே மாதிரி r value calculate பண்ணிட்டு you just by heart it. M r equal to, r is called Rydberg constant, its value is 1.094 into 10 power 7 per meter. Don't forget that. So this is your wave number formula. Now we will see for hydrogen atom what happens to the spectral radiations. Clear? When an electron jumps from the second orbit to first orbit, or from third to first orbit, or from fourth to first orbit, different types of radiations are emitted. ஒரு ரேடியேஷனுக்கும் ஒரு வேவ் நம்பருக்கும் ஒரு wavelength இருக்கும். For hydrogen atom, we will see the different types of spectral series. One by one. So take down this final formula alone. Wave number formula alone. For hydrogen atom. See, this is your first orbit, second orbit, third orbit, fourth orbit. Clear? See here, when the electron jumps from its second orbit to the first orbit, the difference in energy level between these two will be emitted in the form of radiation. Clear? So second orbit la first orbit ku emit pannalam. Then it can also jump from third orbit to first orbit. Idu ellame adunde higher orbits thane. First orbit la irukra electron ku 2, 3, 4, 5, 6 goes on. இது எல்லாமே அதோடைய ஹையர், அது எனி ஒன் ஆஃப் த ஹையர் ஆர்பிட்ஸ்லேருந்து அது ஃபர்ஸ்ட் ஆர்பிட்டுக்கு ஜம்ப் பண்ணுச்சுன்னா the difference in energy level between these two will be emitted in the form of radiation. So it can also jump from fourth to first orbit and it goes on like this. Now if an electron jumps from any of its higher orbit to the first orbit, the difference in energy level will be emitted in the form of radiation. That spectral series he called it as Lyman series. அதுக்கு என்ன பேரு? Lyman series. So first one we will see when n1 equal to 1 and n2 equal to 2, 3, 4 etc. This type of series we call it as Lyman series. Can you write the wave number formula for Lyman series? Now n1 theriyum, n2 also I had given. Clear? Here in this Lyman series, what is the n1? எந்த ஆர்பிட்டுக்கு எல்லா எலக்ட்ரான்ஸும் ஜம்ப் பண்ணுது? ஃபர்ஸ்ட் ஆர்பிட்டுக்கு தானே ஜம்ப் பண்ணுது. So n1 is 1, n2 may be 2, 3, 4, whatever it may be. It goes on. So I can write this wave number formula as r into 1 by 1 square minus 1 by n2. Let it be n2 because n2 may be 2 or 3 or 4, whatever it may be. அதனால higher orbit தானே square. So 1 by 1 square என்ன ஆகும்? 1. So this is your wave number formula for Lyman series. The spectral radiation will be visible in the ultraviolet region. இது எங்க தெரியும்? UV regionல தான் தெரியும். நம்ம இந்த spectral series எல்லாம் அந்த Lyman series எல்லாம். Second one. So there are so many different possibilities. இது ஒரு possibility. Higher orbits வந்து first orbit jump பண்ணலாம். But இங்க second orbitக்கு அது third orbitல இருந்து second orbit jump பண்ணலாம் இல்லையா? அதே மாதிரி fourth orbitல இருந்து jump பண்ணலாமா? fifth orbitல இருந்து அது jump பண்ணலாம். So if an electron jumps from any one of its higher orbit to the second orbit, the difference in energy level will be emitted in the form of radiation. Those spectral series we call it as Balmer series. அதுக்கு என்ன பேருமா? Second one is Balmer series. In Balmer series, what is n1? n1 is 2, n2 3, 4, etc. It goes on. So when electron jumps from third orbit to second orbit, this one he called it as H alpha line. Okay, அந்த spectral radiation க்கு பேர் என்னமா? Fourth ல இருந்து third jump பண்ணிச்சா அது that is we call H beta. Fifth ல இருந்து second க்கு jump பண்ணா that we call as H gamma line. It will be goes on like that. So this type of spectral series, when an electron jumps from any of its higher orbit to the second orbit, that spectral series we call it as Balmer series. This Balmer series will be visible in the visible region. எங்க தெரியும் இந்த Balmer series? visible region. Wave number formula R into 1 by n1 square is 4 minus 1 by n2 square. Yeah. Then what is the other possibility? An electron can jump from any of its higher orbit to the fourth orbit. Now n2 third orbit. This is the third orbit. Fourth la irundhu third ku varalam, fifth la irundhu third ku varalam, adhe mari sixth orbit la irundhu third ku varalam. It will be going on like this. So if electron jumps from any of its higher orbit to the third orbit, that type of spectral series we call it as bracket C, Lyman-Balmer, third one, Pascal. That type of spectral series we call it as Pascal series. Here n1 is 3, n2 4, 5, it goes on like this. Wave number formula R into 1 by 9 minus 1 by n2 square. Clear? This spectral series will be visible in the infrared region. In the spectral series, in the region infrared region. Fourth one, what is the other option now? அடுத்தது என்ன? இது third orbit la jump பண்ணுது. The electron may jump from any of its higher orbit to the fourth orbit. Fifth la irundhu fourth ku varalam, sixth la irundhu fourth ku varalam. This type of spectral series we call it as bracket series. Here n1 is, what is n1? What is n2? 5, 6 and goes on like this. So wave number formula R into 1 by minus 1 by n2 square. Here this also, this spectral series also is visible in the infrared region. So Pascal, bracket, the fifth one is your fun series. All the series are visible in the infrared region only. Appa fun series konda n1 inna 5, n2 6, 7, it goes on like this. What is the wave number formula? Wave number equal to R into 1 by 25 minus 1 by n2 square. So this one is an important 5-mark question. You have such a easy question. Just you draw the diagram neatly and you mention what happens when electron jumps from to the first orbit from its higher orbit. Second to second higher orbit. ஒவ்வொன்றுத்துக்கும் ஒரு பேர் கொடுத்திருக்காங்க. இந்த சீரிஸ் எந்த ரீஜன்ல விசிபிள் என்றதும் எழுதணும். First one Lyman series எந்த region? UV region. Next one Balmer, Pascal, infrared region. Bracket series, Fund series. So it will be easy for you. Clear? So important 5-mark question and easy to write also. Take down. Lyman series, Balmer series, Pascal, bracket, fund, frequency எல்லாம் முடிச்சிட்டோமா? எனர்ஜி முடிச்சிட்டோம் இல்லையா? எனர்ஜி ஆஃப் தி எலக்ட்ரான் ஷார்ட் கமிங்ஸ் இல்லையா? இதெல்லாம் முடிச்சிட்டோமே, எனர்ஜி தான் பார்த்துட்டோமே. Sodium and mercury vector. See, listen here. So in Bohr's theory, what he told first, what is the main thing he did in Bohr's theory? He told about what he discussed, how the electrons will be revolving around the nucleus in a circular orbit. So those orbits, it will not revolve in all permitted orbits. Only certain permitted orbits are allowed for its rotation. In those orbits, it will not radiate any energy. And then the stationary orbits, non-radiating orbits. So when it emits radiation, when it jumps from higher orbit to lower orbit, and the difference in energy level or radiation emit pannum. Idella Bohr solitary, isn't it? But there are some shortcomings of this Bohr's theory. He didn't explain about the electrons eppadi arrange aayirukkum. Adha pathi sonnara avara. He didn't told about that. He didn't explain about the arrangement of electrons in its orbit. Irukkum sonnar. Circular orbit la suttum sonnar eppadi radiation emit agudhu. That and all he told. But he didn't explain about the arrangement of the electrons. Arrangement pathi sollala. Then there is a intensity variation of the spectral radiation. That also he can't able to explain. Then fine structure. When a radiation is viewed through a spectrometer, or a high resolving power spectrometer which and the radiation பார்க்கும்போது spectral series பார்க்கும்போது ஒரு radiationல ரெண்டு fine lines தெரிஞ்சது. In each radiation he can able to ஒரே ஒரு spectral radiation எப்படி தெரிஞ்சது? ரெண்டு lines closer ஆனது. Two fine lines he can able to view when it is when this radiation is able to is viewed through a fine high resolving power spectrometer. ஒரு high resolving power spectrometer வச்சு பார்க்கும்போது ஒரு spectral line ரெண்டா divide ஆச்சு. This we call it as the fine structure of spectral series. இதுக்கு பேர் என்னமா? Fine structure of spectral series. Thus he can't able to explain. இது எதனால தெரிஞ்சது? எதனால இப்படி split ஆகுது? It consists of two fine lines. ஒரு radiationலயே ரெண்டு lines தெரியுது. இது அவரால explain பண்ண முடியல. This is another drawback of Bohr's theory. Then when those radiations when it is kept in a electric field or magnetic field, அப்ப என்னங்கோ there will be a change in its the path. இல்லையா? அந்த spectral radiations electric field ல வைக்கும் போது magnetic field ல வைக்கும் போது ஒரு radiation ரெண்டா divide ஆச்சு. It split up into its fine structures. Thus how it is possible he can't able to explain. First electric field ல வைக்கிறதால fine structure கிடைச்சுனா that we call it as a Stark effect. He can't able to explain the Stark effect. Magnetic field வச்சு இந்த effect பார்த்தார்னா that we call it as a Zeeman effect. So this is also another drawback of the Bohr's theory. இதெல்லாம் drawback இருந்தது. Fine structure explain பண்ண முடியல அவரால. Then another scientist came called Sommerfeld. He can able to overcome the difficulties faced by Bohr. இவர் என்ன நினைச்சாரு? The fine structure of spectral series இருக்குல்ல இதை overcome பண்ணலான்ட்டு he took the Bohr's theory and he discussed his ideas and he told that electrons will not revolve around the nucleus in circular orbits, it will revolve around the nucleus in elliptical orbit. அதுதான் Sommerfeld சொன்னார். எப்படி சுத்துது? elliptical orbitல சுத்திட்டு இருக்கும்போது I have to consider two main factors. One thing, அந்த distance எப்படி இருக்கும்? electron சுத்திட்டே இருக்கு nucleus சுத்தி. அப்ப the distance how it will be? It will be rotating in a, it will be revolving in a elliptical orbit. Appa the distance between the electron and the nucleus will be different at different positions. Distance மாறுமா? இல்லையா? அந்த nucleus distance மாறும்போது velocity என்ன ஆகும்? Velocity changes, isn't it? So when the electron is here, இங்க இருந்து இந்த position போச்சு. So the angles we call it as azimuthal angle. This angle also I have to take into consideration. If I told that electrons are revolving in a elliptical orbit. இந்த ரெண்டு main consideration கொண்டு வரணும். Previously Bohr theory வச்சு we have seen only the principal quantum number n. என்ன பார்த்தோம்? Bohr theoryல ஒரு principal quantum number n மட்டும் தான் பார்த்தோம் since it is revolving in a circular orbit. This principal quantum number gives you the energy of the electron. Energy determine பண்ணும். இது principal quantum number. But if I consider this elliptical orbit, I have to take into consideration another quantum number called azimuthal quantum number or orbital quantum number. What is the other name for it? Azimuthal quantum number or orbital quantum number. Symbol for it is L. So in the rendu quantum number, this new quantum number introduce pannaru. How I can determine this L value? The L determines this angular momentum of the electron. This azimuthal quantum number determines the angular momentum of the electron. So I want to find out this L value. L value ranges from 0 to n minus 1. L value எப்படி இருக்கும்? 0 to n minus 1. This is the form. One by one we will see what happens to this. Here electrons வந்து elliptical orbitல சுத்திட்டு இருக்கும்போது we will see how the radiations effective fine structure எதனால வருது அதை explain பண்றதுக்கு தான் இதெல்லாம் சொல்லிட்டு இருக்காரு அவர். One by one we will go. When the electron is in its first orbit n equal to 1. அப்ப B என்ன ஆகும்? So one more thing, the semi major semi minor axis. So because distance மாறுது இல்லையா? nucleus and the electron வந்து இங்க இருக்கும்போது distance என்ன இருக்கும்? far away from the nucleus. When it is here, it is closer to the nucleus. So this we call it as a semi major axis and this we call it as a semi minor axis. So B and A he has taken here. There is a formula relating the semi major and semi minor axis. B by A equal to L plus 1 by n. B by A equal to L plus 1 by n. Now when it is electron is in first orbit, L can take how many values? How? L equal to n minus 1. அப்ப என்ன ஆகும்? 1 minus 1. L equal to 0. When n equal to 1, L equal to 0. Clear? Now you substitute these two values in the formula and you find out what is the semi major and semi minor axis. L equal to 0, n equal to 1. 0 plus 1. 1. 1 by 1. 1. So when the first orbit this B by A will be equal to 1. Or I can write B equal to A. இல்லையா? அப்புறம் என்ன அர்த்தம்? செமி மேஜர் ஆக்சிஸும் செமி மைனர் ஆக்சிஸும் வேல்யூ சேமா இருக்கு. அப்ப அது எலிப்டிக்கல் ஆர்பிட்ல இருக்குமா சர்க்குலர் ஆர்பிட்ல இருக்குமா? சர்க்குலர் ஆர்பிட். So here when the electron is in its first orbit, it will be having a circular orbit. Clear? In orbit shape here he has taken into consideration, he has given a new one called suborbits or subshells. So first orbit the first orbit is 1s, 1s orbit. Now we will go for the second orbit. N equal to 2 L can take how many values? When n equal to 2, say what are those values? N equal to 2, L equal to n minus 1, 0 and n minus 1 values pogum. L can take how many values? 0 to n minus 1. Appa 2 minus 1 in 1. Appa how many values it can take? 0 and 1. So I can have two different. N equal to 2 irukkumbodhu L vandu azimuthal quantum number 0 ah irukkalam. One more thing, L equal to 1. There are two values, isn't it? So for this, can you find out what is semi major and semi minor axis? B by A formula substitute pannidha enna agum? B by A equal to L plus 1, 1 by 2. Clear? But B equal to A by 2. So if those two values are same only, it will be a circular orbit. Now it is not a circular orbit. It will be having a elliptical orbit. Purida? Here. What is B by A? L plus 1, 1 plus 1 is 2, 2 by 2. So it will be equal to 1, B equal to A. When B equal to A, it is circular orbit. Can we write for n equal to 3? So this orbit he called it as 2s. This one 2p. Can you write for n equal to 3? N equal to 3 means L can take how many values? 0, 1 comma, then B by A. N equal to 3, L equal to 1. N equal to 3, 2. L can take 3 values. For this, what happens to B by A? 0 plus 1, 1, 1 by 3. But B equal to A by 3. So it will be elliptical orbit. So this one is 3s orbit. In the suborbit, 3s orbit. So over electron, when it is revolving around the nucleus, for nucleus second orbit in the first orbit elliptical. 2s orbit will be elliptical and 2p orbit will be circular. This is what he told. Like this only the electrons will be as subshell suborbits kondu vandar. Yaru? Sommerfeld interval. So n equal to 3, third orbit la irukumbodhu azimuthal quantum number 1 ah irundha B by A enna agum? 1 plus 1 by 3. But B by A equal to 2 by 3 or B equal to 2A by 3. That is, it is not a circular orbit. Again, it is a elliptical orbit. This orbit he called it as 3p orbit. Suborbit, subshells. Here, B by A equal to 2 plus 1 is 3. 3 by 3, 1. Appa B equal to, so it will take circular orbit. This rendo elliptical. So first irukra 3s, 3p orbit is elliptical. Third orbit is 3d orbit. This will be circular. Purida? So like this only electrons will be revolving around the nucleus. He gave the how the electrons will be revolving around the nucleus in solitar. Arrangement is solala. By this he can able to explain this. அதாவது எலக்ட்ரான் எலிப்டிக்கல் ஆர்பிட்ல சுத்திட்டு இருக்கும்போது வெலாசிட்டி சேஞ்ச் ஆகுமா? டிஸ்டன்ஸ் சேஞ்ச் ஆகுது இல்லையாமா ஃப்ரம் த நியூக்ளியஸ்? டிஸ்டன்ஸ் சேஞ்ச் ஆக வெலாசிட்டி சேஞ்ச் ஆகும்போது will the mass be the same at all the places? மாஸ் சேமா இருக்குமா எலக்ட்ரானுடைய மாஸ்? Because it is taking a elliptical orbit. When it is taking elliptical orbit, since there is a change in velocity, I have to take into consideration the important one, the relativistic mass variation of the electron. And the relativistic mass variation of the electron I can able to explain the fine structure of the spectral series. On the basis Sommerfeld he can overcome the difficulty of Bohr's theory. In the basis explain pannar on on the basis of relativistic mass variation of the electron when it is revolving around the electron, the nucleus in a elliptical orbit. Nucleus சுத்தி elliptical orbit la சுத்தும்போது the relativistic mass variation consider பண்ணும்போது தான் he can able to overcome the difficulty done by Bohr. Fine structure series, fine structure of the spectral series explain பண்ணாரு. But if he did the same calculation how Bohr did for energy to find out the energy of the electron in its nth orbit, he got the same value as Bohr got. Sommerfeld அதே பண்ணி பார்த்தாரு calculation energy of the electron in its nth orbit. போருக்கு என்ன வேல்யூ கிடைச்சதோ அதே தான் வேல்யூ கிடைச்சது. இவர் என்ன சொன்னாரு, அவர் சர்க்குலர் ஆர்பிட் சொன்னாரு, இவர் எலிப்டிக்கல் ஆர்பிட் சொன்னார். பட் இவர் எலிப்டிக்கல் ஆர்பிட் சொன்னா எனர்ஜியோட வேல்யூ மாறணும் இல்லையா? ஆனா சர்க்குலர் ஆர்பிட்ல சொல்லும்போது என்ன ஃபார்முலா கிடைச்சதோ அதே தான் சோமர்ஃபீல்டுக்கும் கிடைச்சது. பட் இட் இஸ் ஆஃப் நோ யூஸ் இன் சேயிங் தட் electrons are revolving in elliptical orbit around the nucleus. ஏன்னா same value கிடைச்சது for energy. On this basis only he can able to explain the fine structure of the spectral series. So he overcome this difficulty, but he didn't say the arrangement of the electrons. First orbit level இருக்கும், second orbit level இருக்கும். This and all he didn't told. Then the same drawbacks what Bohr told, what Bohr gave, same drawbacks also Sommerfeld had. Sommerfeld auto modelக்கும் அதே drawbacks தான் இருந்தது. Bohrக்கு இருந்தது இல்லையா? He can't able to explain the arrangement of the electrons. He can't able to explain the Stark and Zeeman effect. Then intensity change ஆகுது, spectral radiations ஓட intensity vary ஆகுது. This also he can't able to explain the variations of the intensity of the spectral radiations. All these are the drawbacks of Sommerfeld atom model.